Now let's see question number 7. Using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Okay, recall that what you have proved it in class 9. Okay, this is midpoint theorem, which you have proved in class 9. We are going to use theorem 6.1, that is basic proportionality theorem. Okay, so let's draw the figure here. Okay, let's call it ABC. Now what the question says is, if a line is drawn through the midpoint of one side of a triangle. Now let's take the midpoint of one side. So let's take the midpoint of this side AB, and then through this let's draw a line parallel to BC. Now let's call this D. Now this line is intersecting AC at E. Let's call it E. Now what we're going to prove is, we're going to prove that this line DE bisects this line AC, which means you have to prove that E is the midpoint of AC, that is AE is equal to EC. This AE line is equal to EC line. So let's write given here. Given is a triangle ABC. A triangle ABC, and DE is a line drawn parallel to BC through the midpoints D of AB. DE is a line drawn parallel to BC through the midpoint D of AB. Now to prove this, now we have to prove that this DE bisects AC. DE bisects AC. What does this bisects means? What does this bisect means? Bisecting a line. So bisecting a line, bisect, it simply means dividing into two equal parts. Now if we have a line here, and if a line cuts this line here in such a way that this is the midpoint, it means, for example, if this line is 8 centimeter and if this is 4 and this 4, that means this line has exactly divides this line into two equal parts, this part and this part. We say that this is this line is bisecting this this line, which is 8 centimeter. Now let's prove this. Now this one, we're going to apply basic proportionality theorem here, because these two lines are parallel. So since these two lines are parallel, we can say that AD by DB is equal to AE by EC. So we have DE is parallel to BC. This is given. Therefore AD by DB is equal to AE by AC. This is by basic proportionality theorem. Now D is the midpoint of AB, so which means AD is equal to AB, which means this AD is equal to AB. This line and this line are equal. If this is 3 centimeter, then this one will be also 3 centimeter. Now when we divide a number by by the same number, then it is 1. So AD by DB, they are equal. So since they are equal, AD by DB will be equal to 1. Will be equal to 1. A number divided by the same number, 3 by 3, let's say 3 by 3 is equal to 1. 4 by 4 is equal to 1. Any number divided by the same number is always 1. So AD by DB is equal to 1. Now this is equal to 1. This AD by DB is equal to 1. A by AC. Now you have to write the reason here. Why this is 1? Because AD is equal to DB, as D being the midpoint of AB. Now this implies that AE is equal to EC. Cross multiply this, you will get AE is equal to EC. So now we have got here AE is equal to EC. AE is equal to EC, which means E is the midpoint. This shows that DE bisects AC. Recall that bisecting a line means dividing the line into two equal parts. So if DE is bisecting AC, then E should be the midpoint, because this AE should be equal to EC. So here what we got here is AE is equal to EC, so which means that AE part and EC part are equal, and this has been divided by this line. So now we say that this implies that DE bisects AC. Now let's see the next question. That is question number 8. Using theorem 6.2, prove that a line joining the midpoints of any two sides of a triangle is parallel to the third side. Okay, let's draw the figure for this. We have a triangle here. Let's give the name ABC. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So here we're going to join the midpoints of two sides. So let's say the midpoints of AB is D, and the midpoints of AC is E. Now we're going to join these midpoints. Now what we're going to prove is this line joining the midpoints D and E is parallel to BC. So that is what we're going to prove. So first let us write given. Given is, here we have a triangle ABC, in which D and E are the midpoints of AB and AC respectively. Now to prove is DE is parallel to BC. DE parallel to BC. Now here we will find the ratio of AD and DB, and also the ratio of AE and EC, and if they are found to be equal, then we can say that these two lines are parallel by converse of basic proportionality theorem. So let's find AD by DB. Now AD by DB is equal to, now D is the midpoint of AB, which means AD is equal to DB. Now if we divide a number by equal number, example 3 divided by 3, then the answer is 1. So likewise AD by DB will be also equal to 1 because these two are equal. So AD by DB is equal to 1 since AD is equal to DB, as D is the midpoint of D, you can say D being the midpoint of AB, and also on the right hand side AE is equal to AC, so AE by EC will be again equal to 1 because E is the midpoint. This AE line, AE and EC are equal. If this is 4 centimeter, this will be also 4 centimeter. So you have to write here, since AE is equal to EC, as E is the midpoint of, being the midpoint of AC. Now AD by DB is equal to 1, AE by EC is also equal to 1, which means this one and this one are equal because both this are equal to 1. Therefore AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. What we got here is AD by DB is equal to AE by EC. Now since the ratio on this side and the ratio on the other side are equal, now we can say that DE is parallel to EC. This implies that DE is parallel to BC. This is given by converse of basic proportionality theorem. Converse of basic proportionality theorem. So this is the proof of this question.